Good evening, Python class. This week we're going to be covering exclusively Chapter 4, straight from the book. There's apparently been a large volume of complaints that we don't cover enough book topics or reference book material directly. So we're going to do that this week and see if we have better results as far as feedback is concerned. Those of you that are actively doing and handing in the assignments, you're doing great. Just keep it up. So Chapter 4 is exclusively about Python collections. So we've already talked about collections. This is the formal chapter that covers collections for those of you that have been looking up things in the book and referencing the book. Chapter 4 covers lists and dictionaries. It actually contains verbatim an answer to a previous assignment that we had. It was regarding the mean, standard deviation. It has the answers to all that in there. And it had verbatim another answer, which I think it was like the min and max answer that we had for an assignment a while ago. Yeah, so it has a function that calculates the maximum value of an item in a list. So, but we're going to cover that just for review, if nothing else. This is going to be, I believe it's a 25-point assignment. It's pretty straightforward and easy. It's either 25 or 30 points. It's up on the Dropbox. I'll go ahead and look now to remove any confusion. Oh, somebody's already handed it in. It's a 30-point assignment. So I think it's pretty straightforward and easy. There's two parts to the assignment, and the reason why there's two parts is because I've actually axed one of the parts. If you're following along in the book, you notice that there's a graphing library that they continuously reference. It's called Turtle. I personally don't like Turtle, so I've chosen to avoid chapters that cover Turtle. When you get to the real world and start doing Python professionally, Turtle is not the graphing library that you would use, so I chose to avoid teaching you that. I think it's a complicated, overly complicated graphing library. The one that people use in a professional setting is much more simple and straightforward and extremely powerful. Turtle is very basic, and if you remember the program at all called Logo Writer, Turtle was modeled almost exclusively after Logo Writer, so it's very rudimentary stuff that we're talking here. But that being said, I got rid of that part of the assignment. So the part of the assignment that asks you to graph the results, you no longer need to do. But in addition to using random.uniform to generate your list of 1,000 numbers in the range of 0 to 50, I went ahead and said and do the same thing for random.gauss as well. So we're going to talk about these random functions that I'm having you use, and I'm going to use the Python interpreter directly. So as you can see, I loaded up my command prompt, typed Python, and now I have a Python interpreter, interactive interpreter loaded. So I'm going to import random. Okay, so now I have the random module imported. It's a default module with Python. They don't really cover the random module in this chapter, which is why I'm going to go ahead and show you how to use these two functions that the book has requested you use. So we're going to say help. Help is a function in Python. And we're going to say help us with random.uniform. And what this does is it prints out the Python documents for the function. And so it says help on method uniform in module random. Uniform takes two arguments, a and b is what they call them in the help. It's a method of random.random instance. So since it's an instance method, we're going to have to create a random object and then call the uniform member method of that object. So I'm going to go ahead and do that right now. I'm going to say r equals random. Is it .new or is it new random? Random is not defined. Well, how do we make a new random object? We're just going to call help on random altogether. And for version 3 of Python, it may have lied to us. We might actually not even need to create a random object. So let's just load up our help again. Random.uniform. So it says we need to call it on a random instance, but I actually think random is an instance of the random module in Python 3 and above, so we're not going to do that. But it's going to get a random number in the range of A to B. So what I'm going to do is say random.uniform. I want a number between 0 and 50, right? And there we go. I got 40.22 some other stuff. I'm going to do it again. 43.85, 46, 22, 5, 8, 17. So the dot uniform leads me to believe that these are going to be uniformly distributed random numbers. So if we called this function 1,000 times and took the average of a random number between 0 and 50, the average should be 25, right? And that's what it's going to have you do in the assignment. It wants you to graph the frequency distribution along with the mean and standard deviation. But I don't want you to graph it, I just want you to print those things. And if you want to know in more detail how to print the frequency distribution along with the mean and standard deviation, please just read the chapter. If you don't have the book, I will give you a small time extension to allot for maybe 2 or 3 days of book acquisition, making your official due date for this assignment no later than next Tuesday. So keep that in mind. Just make sure to procure the book as soon as possible. So, and then we have a random.gauss function. So let's call help on this one again. What does random.gauss give us? So Gauss takes a mu and a sigma of a random instance. Mu is the mean and sigma is the standard deviation. This is slightly faster than normal variate function. This is not thread safe. Okay, so it wants us to use random.gauss to generate a list of 1,000 numbers in the range of 0 to 50. Well, how are we going to do that? How are we going to do that with a mu and a sigma? So if mu is the mean and sigma is the standard deviation, what I'm going to do is say random Gauss, I want the mean, which is the average, to be 25, and I want one standard deviation of the numerical set to be 25. If you've taken statistics, you know that this is essentially the plus or minus associated with the value. So we should roughly get numbers within the range of 0 and 50. As you can see, we do get numbers sometimes that are outside of the standard deviation we've specified, but that's fine. After we generate 1,000 numbers, it should even back out, and we should have an average of 25 again. At least this is how I want you to use this. You can lower the standard deviation if you want. So with 15, you're going to get numbers that are closer to 25. We just got one that's almost 2 standard deviations away, which is, I would think, not common. I got a -7. There's a 43, -4, 48. So a standard deviation of 15. It's if you take your standard deviation all the way down to 1, you're pretty much going to get numbers that are plus or minus 1 or 2 away from the mean that you've specified. And if you take your standard deviation back up to 25, you're generally going to get numbers in between the range of 0 to 50, if you understand how a standard deviation works. No big deal, so just make sure to use a standard deviation no greater than 25 for the second part of the assignment. And so what it's going to have you do is generate a list of 1,000 numbers like this. So I'm going to go ahead and just do this right now. So I'm going to say my list of nums, and I'm going to use sorry, I'm drawing a blank. List comprehension for this. Random uniform 0 to 50 for x in range 0 to 1,000. So this should give us 1,000 numbers in the range of 0 to 50. Alright, so if we go ahead and print out our list of nums, there's my list of numbers. There should be exactly 1,000 of them, which there are. So now we can go ahead and import that math. I had you guys import statistics for a previous module. For this one, the book is using math, so we're just going to go ahead and import math. The only difference between math and statistics is math takes some computational shortcuts that make some of the more advanced statistical computations less accurate. There's functionally the same though. So what we're going to do then is, I think we can just call mean on it now. Let's try to help on mean. Is it math.mean? Module has no attribute mean. Well, let's help with math. Seems to help us out before. So we've got some trig functions there, still in trig functions. We get some exponents, some mods, factorial, getting close to the mean, median, mode area. Little log, mod, power. Oh wow, it actually doesn't have the function that we need, but I see them using it in the book. So how are they getting this out of the book? Are they using statistics? Doesn't appear to be using statistics. You know, the book might actually be using a different version of Python. So let's just go ahead and use the statistic module again. They may have moved the statistics functions into the global library in the previous version of Python, and then moved it into statistics for this one. I can type, I swear. So you can, here's another little shortcut. So instead of typing statistics every time, we can say import statistics as st. So now when I call st, it's like calling statistics. So it's just a way to shortcut very long module names that you want to type a lot. So let's just do st mean list of nums. And there's our list, our mean for our list of nums. Pretty straightforward. And then it wants the standard deviation. So let's go ahead and see how to calculate the standard deviation. It's got mean, median, mode. And it should show us in this help standard dev right there. So just call stdev with your list. Let's go ahead and do that. Oh, st. I imported statistics as st, don't forget. Our list of nums. And there's the standard deviation for the random list of numbers that I generated. Obviously, unless some crazy parallel universe exists in your computer, you should get different results for your mean, standard deviation, and mode than anybody else in the class, right? So let's see if we have a mode function here. I would be very shocked if, yeah, they're all unique. So it found 1,000 equally common values, meaning that we don't have a mode for the set of numbers that we passed into the standard, or into the mode function. All the numbers were unique. So that's expected when you're generating random numbers with the type of decimal precision that the standard deviation, or the random.uniform function returns. So that's pretty much how to get started on the assignment. Again, just read chapter 4 if you don't have a good understanding on lists or dictionaries yet. I realize that the assignment that I gave you out of the book doesn't reference dictionaries at all. I think dictionaries are a little more complicated than lists, but this should be a good starting point for going back and revisiting those statistics functions that we've used in the previous module. I think module 4 was the one that we were doing the statistical analysis. So please just get the book. If you don't have the book, get the book. If you don't have the book, let me know you don't have the book so I know why you don't hand in an assignment at the due date. And after you get the book, read chapter 4 and then do exercises 4.44 and 4.45 from the book, with the exception of not using the graphics. Do not try and graph these things using Turtle. They've covered Turtle in previous chapters of the book, and then later on they stop really talking about Turtle. I'm choosing to not do Turtle. Now, this assignment does have 30 points of extra credit associated with it as well, meaning that this is a 30-point assignment, but it could be 60 points if you choose to go above and beyond my expectations. So the 30 points extra credit is to download the real graphing library that people use professionally. It's called Matplotlib, and so it's PyPlot is the Python conversion of Matplotlib. It makes very elegant graphics that are relatively simple to set up, configure, and use. For instance, if you wanted to plot a simple histogram, which is what you would do with this, it's probably 20 lines of code, but you set up your x-axis, you set up your y-axis, you pass it in the data that you want, you set a title, you tell it whether or not you want a key, what the key represents of the what the key values are of the graph. So, you know, if you have different colored items on your graph, like you have a blue line and a red line, I realize this doesn't apply directly to single data set histograms, but you can have a key that just says, hey, the blue bars are my number values, and it appears on your graph. So it's pretty easy and straightforward to use. And if you want the extra 30 points credit, just go ahead and try to use it. Just like when we installed, Control Z out of here. Just like when we installed Pylint, so I have Pylint, except I don't really want to use it interactively like that. You're just going to do a pip install, I think it's PyPlot, and there we go. I am installing PyPlot right now. And so if you do that, you'll have the PyPlot module on your computer, and then you can use it and get the 30 points extra credit. Oh, no items found for PyPlot. Let me pull up the exact Matplotlib. It's actually called Matplotlib. So there we go. We have to download NumPy, which is a requirement of Matplotlib, and it's actually going to install it. So sorry, I may have misled you by saying PyPlot or whatever. It's actually just Matplotlib still. And that concludes this lesson. If you have any questions, don't hesitate to email me. I'm here most of the week. I've Skyped with several students in how to do the exercises. This is straight from the book. I would say it's easier than Module 4, but at the same time uses the almost identical technology that we were using before, except instead of reading in a file, you're just going to generate a list of random numbers instead of just generating a list of count values for characters. So it's kind of similar, but a little different. Again, any questions, don't hesitate to contact me, and we will not be hosting a live class tonight. This video should be adequate instruction for anybody to get started on the assignment. I didn't do any script writing, as you saw, so my script up here is blank still. I did everything interactively. And being interactive in Python is very powerful. It lets you do those things that I showed you how to do, where you can just generate your list of numbers right there using list comprehension and reference it as a variable and call help on functions if you don't quite know how to use something and you don't want to switch over to look at the Python documentation. So it's very effective for quick, rapid development, and we use it all the time. All right, have a good night.